working with the power. In fact, let me even just briefly explain that part because we want to touch everything that is necessary for you to know because the knowledge helps us to maintain the system. The system is automated, quite all right, but there are things you should still know on how the system works. Let's start with this NEPA input, for example. I do not recommend using NEPA for the system you have because it's actually not useful. But should it be useful, maybe in certain cases, maybe you are working nights and then you need extra power because at night there's no solar energy coming at night. So at that time you need any extra energy. That's where NEPA comes in. But during the day, it's really not necessary. But now, assuming during the day as it is now, or at night that you need NEPA, once NEPA, there's light in NEPA, the power comes in here. This light will show you, and this represents the three phase. Once there's power in the three phase, the three indicators will show you that there's power on NEPA. And when that power comes in, it's automatically routed to the inverter. This is now the central power control system that takes care of everything that has to do with power management, which is this. Exactly. It controls all of them from here. Now, when the NEPA comes in, this man here is going to absorb the energy. If the NEPA voltage is low, it will not accept it. It will reject it and continue working with battery or solar or anything. If it's too high, it will also isolate it and continue working with what you have. So if NEPA comes in within the range as it is now, it will accept it. And when it accepts it, I want you to come closer and look at this. This sign here represents the NEPA. This screen is touch screen. You are not supposed to touch it anyhow. Once you touch, it starts responding. Then I'll tell you what happens should you touch it mistakenly. This sign here represents NEPA.
I've seen the pole.
This one represents the load in the house. This one represents the battery. And this one represents the solar. That's energy from the sun. This number here represents your battery level.
Okay.
You can see it is 100%. So it's always showing your battery level. That battery level is one that you must always monitor. You should always monitor it when you are working. Now, this sound now is from the fan. Whenever the processor inside sees any need to adopt faster cooling, the fan will come up automatically. So it's not a problem. It controls when it goes up and when it comes down. It doesn't really affect anything. So as it is now, you can tell, you can see the energy coming from NEPA. It's very small. It's small because there's still enough energy coming from solar. Okay? So because there's enough energy coming from solar, then the NEPA doesn't have much to do. Because the solar is free. But NEPA, you are paying bill. There's bill attached to it. So that's why it's not giving preference to NEPA. So right now, the load is at 14 kilowatts. This load suggests to me that you are running RO and borehole. Am I correct? So outside that, there's no major load. It's just like the AC and the lighting points. So that's basically what you have. So which means if NEPA goes off now, here becomes 0. Now let me turn off NEPA. This breaker controls NEPA. This one controls generator. And this one is for the solar output. But they are not meant to be operated. It's just for you to know. Unless when it's absolutely necessary. You can run this entire system for months without needing to turn on or turn off anything. You can run it for months. The only thing for you to be able to run smoothly, you just need to make sure that you are monitoring your battery level. Touch this, but don't press it. It's also touch screen. Just touch for it to wake up. You see the battery level. So you have two places to check your battery, either here or here. The screen is also touch screen. If you keep pressing it, will start responding. Now, should you have touched anything here by mistake, maybe you wanted to check something and you touched something here by mistake, for you to continue to touch, you might go and preset or change one setting that might affect something. This thing is escape key. This one, you just press it and it goes back to default. Because maybe by mistake, in place of trying to show somebody or trying to press it, You just press this one, it goes back. This one means enter. You know, in this thing, enter means execute or act or do something. So avoid this enter button. Anytime you mistakenly touch anything, you press escape. You understand? Because there's really nothing that is there for you to set apart from changing something which may not be too healthy. So that takes care of how the inverter system is connected. Now, for the NEPA, let me just turn this off. Now, when I turn this, what it means that the NEPA that comes into the system is disconnected. It doesn't mean that there's no NEPA, there will still be NEPA. But the one that enters into the system, because it's the one that enters here used to work. That one I've just turned it off. Now it goes to 0. Let's assume NEPA take light. It will still go to 0, showing that there's no NEPA. Yes. So, but normally when we finish, I would prefer to leave this one off. The reason I prefer to leave it off is your system is safer and more robust when you are even working without NEPA completely. Ask me why. The reason is because NEPA sometimes when there's fault, which does not concern you, that one is NEPA problem. Their transformer can have problem. Lightning can affect your system through NEPA more easily. If your system is connected to NEPA, there's tendency of surge when lightning strikes power lines. And when lightning affects system, it's not only when the lightning strikes in this building. These power lines are distributed. Lightning can strike maybe in that junction or in that way or in that, and the energy that is fused into NEPA wire will just spread and it can affect your system. So those are surge that usually comes with power. So to avoid the surge and the wahala, you don't even need the NEPA. But like I explained to you now, how can I have NEPA and I'm not using it? When you need it, you should use it. Your tire can burst when you drive on bad road. Does not mean I won't go to bad. You go village now. Do you understand what I'm saying? So, but I can't start going to village when I don't need to go to village. I can't start driving to village. But when it's important that I have to drive to the, I'll drive even if the road is bad. I will go. The tire can burst, no problem. Do you understand? So that's exactly what this one does. So we'll leave it off. Anytime you are working at night and you say, NEPA light, we need it. You just come here and turn it on.
Even sometimes in the rainy season when there is not much sun.
And there's NEPA.
And there is NEPA.
You can turn it off. But there's a problem with that rainy season time. When it's actually raining, like now you look at the weather now and rain is pouring, two things should come to your mind. There's lightning. Lightning occurs during rain. Those lightning and thunderstorm period is a very dangerous period. It affects equipment like this. They are very sensitive. So during that time, this thing should not be on. It should be off. Because during that period, lightning can penetrate easily through those things.
Sorry.
Yes.
Why will NEPA affect this?
Okay.
When maybe you got force at somewhere X.
Yes.
How and why?
Okay. Thank you for your question. Remember I explained that the NEPA wire that you see here is coming from somewhere else. So the same way that wire is coming from somewhere else, if there's any fault with that wire, that fault will travel along with the wire to this place. So if you leave it on and the NEPA is connected, and maybe there's thunderstorm, there's lightning strike that hits that wire of NEPA that is not even here, maybe some distance away, that wire can carry that power. You know, lightning, electricity, it's far high. It's not something you can control. Lightning can tear down a tree. The voltage is too massive. It's not meant for any electronic appliance.
Once your system is on, it will go to
Yes, if that lightning.
it will reverse to any other person that has it.
Thank you. I don't know if I answered your question.
Even if it is on without, even if it's plugged on the socket without being on.
Yes, it can affect. Even there's no light, too. Sometimes it affects. But the reason why that thing happens is that all those things are connected, and due to the power that goes with that lightning, that 1 second it will just push power. Even there's no light, it can affect. It happens. So that's basically on the NEPA array and all that. Most of the other thing is just for you to understand. Like here now, let's assume now there's a fault. For some reason, the inverter have sensed something that made it not to work. Maybe overheating. I don't know what it can be, but for now, I can't think of anything that will make the inverter not to give power. Do you understand? And I don't really predict anything like that. Most of the systems we have run, they have run for months without any interruption that made them not to work. But should anything happen now, for example, and this thing now develops a fault and it's not working, remember this one is the central control that distributes the power. It will take from NEPA, take from Gen, and give. Now, when him is not working, you won't be able to have power. Because he himself, that is the central system that gives power to this, gives power to that, is not working. Okay? Now, this one is the solar output. All the output, the power that is coming from here to go into your system, it comes from here. If I turn off this breaker now, all the lights here, everything will go off. If I turn this one off, everything will go off. And the power from here goes to this. You know, this one is solar, this is NEPA, this is Gen. So once there's power on solar, this will be on. Once there's power from NEPA, this will be on. If there's power from generator, this will be on. So if you turn on generator now, this one will come on. Okay? Now, should this one be off, let's say for any reason this is off, there's need for what we call bypass. Bypass means we want to bypass the solar or anything that has to do with this and power come. You may not need this. The reason I'm just telling you just for you to know. You know, when you enter aircraft, they tell you in case if there's emergency, those standing at the door, they show them emergency door. It doesn't mean that when plane is flying, you go and open emergency door. All of us could die. So, but it's just for you to know in case. So this one too is also just for you to know. It's not for you to use it. Exactly. The escape route you can use. Now, what it means is that this one now is already on solar. Once you take this one now to up, what it will have here is either PHCN or Gen, which now depends on this. If this one is on PHCN, which means what you will have here is PHCN. And if this one is on Gen, what you have here will be on Gen. So which means if I want to use Gen on bypass, I'll switch this one to PHCN or Gen, and then take this one down to Gen. If I want to use NEPA on bypass, I have to take this one up, then leave this one up. That means I'm now using bypass. But this one will always remain here so long as this system is supplying power. There is no need to remove because it's powering everything in the facility.
Yes, I understand. In case this one
In case, just in case, which that in case might be in the next 5 years or it may never even come. You understand? Another thing again you can do is maybe if they are doing repairs or maintenance. And sometimes the people that do repairs or maintenance, the way they use or power or run appliances sometimes is dangerous to our system. They could be breached, not intentionally, by accident. Maybe they plug something, just say, poor, or they plug that kind of a thing. If you have NEPA, it's advisable you can do bypass. Let them use NEPA to do their work and repair and maintenance when they finish. So that, exactly, so that your solar system will be safe. They will do it on NEPA and finish it. That's if there's NEPA. But if there's no way, the only thing you can do is to warn them, please, we are using solar. Don't breach. Don't allow anything to breach. Do you understand? So if you now do bypass, anything they are doing is running on NEPA, so there's no problem to that. If there is NEPA. Do you understand? If there is NEPA. But if there's no NEPA, just like the way the other guys were working there, they were doing their thing. It's just that there was a time when they turned on some things without checking, and the load was getting too high. I was reading, I said, the load has even reached the maximum of the inverter. And we don't allow the inverter to read too much load. The reason why is not because when you put too much load, the inverter will spoil. No. But when you keep running overload on any system, of course, you should know it's like you bought a brand new car. That car is meant to carry load, is it not? But now you now say, since you can carry load, oh yeah, carry this one, join, carry this one. You know, there's a way you put it. Even that car that is meant to carry load will suffer.
The very machine has been boycotted. Even them, they are very self. They are complaining that the very machine is consuming light so much, so there is no need. So we boycotted it to another level.
Which of the machines?
That small one that brings the level.
That does deliver.
He has big heater.
The one that smoke used to come out.
That one can work now. So
No,
what's the
we
problem?
don't even boycott them. That was that time you were watching this thing.
No, but at that time, the reason why the thing was high at that time was because they were running it at the full bottle line, and both RO and pumping machine were on.
Even now, they don't stop that one. We are not using it anymore. We change it to another level.
Okay.
That small hand there.
That small handy thing. Anyway, but assuming that one is there, it will still not be a problem. You understand? Because that's part of why I wanted to see these things work myself, so that I will observe it myself. Yes, because even for me, I'm the one telling you people, I would even prefer they should put it, let's monitor the load. But the major thing we're looking at is if that one runs, remember that one already is load, then you add the bottle water line, which is not much. Then you add the heat shrinker. That whole complete line is one complete system of load that you can be running without any issues. Then if you now want to run another section, like a pet blower, this one is already a heavy load on it, so you can pause this one. You can run the pet blower, run the borehole, RO, pure water, and every other testing apart from the bottle line. Because apart from the bottle line, every other load can run. Both pet blower can run with pure water, it can run with RO, it can run with borehole. All of them can run separately.
Yeah, we have even programmed it that way. Talking. When
Okay.
you blow bottle in a day, we work on bottle line the other day.
Yeah, you can also do it that way, so that when the day for blowing, you do your blowing, do your sachet water, all those other ones. Treat, exactly. Because you can treat from morning till night.
Even now, sir.
It still works because I noticed it. You can treat from morning till night. Because the most important thing is that consistency and knowing how to manage it. Now, when you start doing your bottle water, the bottle water line, most times from 9 in the morning, you can start production. As far as the weather is just normal. The only thing you do that when you are running, it depends on what you are doing. No? The one that consume much, like a bottle water line with shrink wrapper, everything. If all of them are running, your load usually reach between 30-36 kVA. And the capacity here we have is 50 kVA. We want you to run something that will not be more than 42, 43. Once it starts getting to 45, it's becoming overload.
Then where can somebody check that?
Thank you. This is where to see it here. See here now. You'll be looking at this. This is 14.
14.58.
This 14 is like what is normal for borehole and RO. Then with small load like AC and all these other things, they're under this one.
That's approximately 15.
Exactly. If you add bottle water now, it will just be around maybe 20. It won't go more than 20. 20 is still very small. If you add bottle water, as in, sorry, not bottle water, sachet water. If you add sachet water, that one is small. It won't even take much. If you want to even do bottle water without this shrink wrapper, it will still carry it again without the shrink. What makes bottle water line heavy is the shrink wrapper and then that other one. So with this, you can now look at it. Okay, the thing is now going. Once the thing reach 40, it's okay. Exactly. You can maintain within that 40 something. Don't go more than 45. You can do up to 40 something, 41, 42 thereabout, but don't go more than 45. It will carry it if you do 45, as you want to take it to carry it. But that is now overload. It's now at the peak where it's looking for life. So you can do 40 comfortably. So if weather is going down, maybe you started production, I notice there's no more sun. Then what you should be monitoring is the battery. Your mind should always be going to the battery. Now that there's no more sun, what's the rate at which the battery is going down? You'll now be checking, okay, it's going down, it's now 98, 97, no problem. Where you now start having issue is anytime your battery goes below 50%, you might need to maybe stop production.
Shut down.
Not that it will not carry it. That battery can carry anything you are doing until it gets to about 20% or there. But I think between 15 and 20, that's when it will cut off. We don't want you to go close to that cutting off. There are always complications with it. What happens that system will just trip off. And we advise our people, system tripping us, there's impact on the system. Exactly. It doesn't damage the first time, second time, third time. But if you now make it a constant, one day, it will trip something and then it will have issue. So in order to avoid it, to be on the safe side, you just run. When you issue, I say, let's stop the production tomorrow since there's no sun all through. Tomorrow you can continue. That 50% will carry your AC. Don't turn off the AC. The AC, we have set it on temperature. We usually set on 26. If for any reason you remove it from 26, You can increase it maybe like during the day, but it must come back to that 26. That temperature set on 26 is just what makes the ambience normal. This battery is designed to last more than 10 years. The warranty on this battery is 10 years. But the condition is that the environment where it is kept is conducive for it, including the inverter. So if somebody has given you this battery, tell you once you put it in a conducive environment, you can enjoy this battery for 10 years without stress. I think it's a good buy. The only thing that we require is we've already have the AC. Make sure the AC is on to just maintain the temperature. The AC, when it's on, is not completely on because it has its own working mechanism. Once you set that temperature, most times into the night when temperature doesn't rise, it is actually off. But it's on here, but the internal working this thing is actually off. So it offs and ons itself on set temperature without you interrupting. So it's actually on 24 hours, but it's not working 24 hours. So don't stress yourself on that one. So one of the systems we do is that this system will allow it to run 24 hours. So part of the things I'm teaching is that you need to allow the system to run continuously 24/7, no interruption. On its own, it will be working. The only way you can make it to go off is if you run down the battery, the system will go off, or you go and turn off something, the system will go off. Even when you want to do bypass, like I said, maybe there's technical work you need to do. You don't need to off the system. There's nothing to off. You remove this one, the power of the building will supply, but the inverter is still working, it's supplying, but you are not using its own power. You understand? Even when you do the bypass. So the way the thing is, let it just be on running. And then the system is online. I will show you the app. On the app, once you go to App Store, I don't know if you have internet. You go to App Store, you search for F Solar. The essence of having that app working, very, very good, is that you do not need to be in the factory to monitor your battery and what. You can leave workers working and you went to do supply. And it's not something that one person should be doing. Everybody should be monitoring. You can be somewhere supplying and your mind is like, let me check what they are doing. I hope what they are doing is in order. From the app, you can check and see whether they are running the system the way it's supposed to be. If they are not, you can place a call and tell them, check this, check that. Go to App Store, look for F Solar while I... Okay. So that you just download the app quickly and then we... Manager, have you seen it? Network is another thing. No? This network, I have to do something. The network for this thing, the one that this inverter is using, I think we put it in that building. Ben, where is it plugged? Is it in that warehouse inside? The reason we put it there is because there's better network there. And the network there is reaching here. You understand? So you can use that one.
That one, what is the code of that one?
That one, let me give it to you now so that you can use it. So you can use that one to connect and... Where did I keep that one?
That one, you go to Wi-Fi.